Get up quality. Get up quality. Stop sleeping in hours. Get up quality. Stop sleeping in hours. Get up quality. Stop sleeping in hours. Get up quality. Get up quality. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, January 28, 2022, Friday, 3:45 मॉर्निंग। नमस्कार, मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया देश से बोल रहा हूँ। आज जनवरी 28, 2022 शुक्रवार सुबह के 3:48 और मैं आपके सामने क्वालिटी इशू को लेकर फिर दोबारा once again I am here with you to have brief about quality, brief talk, only few hours, not more than that. Quality, very important part of life, and this is my tablet, this is my name board with my address. You can see at line address is this, and my email ID is this. You can read that. Spelling is same as my name, SURAJ_engineer, spelling of engineer, ENGINEER, and yahoo.co.uk. You are requested to write to this mail if you are having any question. And this is my title, you can read yourself, I'm not explain again and again. And there is certification valid up to September 30th, 2025. That's INT P India, and here is Chartered Engineer India, and here is Fellow. And not to waste time, quality that I'm inclined to talk every day in addition to engineering issues, concrete issues which are very, very important. And then we can discuss about concrete, that is very much required to be discussed. Concrete, I have already discussed this one. We have to see about other issues. Concrete, important item which cannot be just considered for granted. I tried to find many files and I could get only one file, and that was ACI concrete terminology, which is very significant one for everybody and also for you and for me. Concrete terminology, for which I spend a lot of time to understand, and again it is here for you. Not to go to that level, I shall like to come to point and state about I close this certificate of fellow, I close this certificate of chartered engineer. I keep my name board and INT certificate because this talk is national and international both. I'm talking about our country. You can see what I've written on this short. Get up quality, stop sleeping in hours. Engineers can handle you successfully. We require to establish you permanently, have active quality performing applications, quality SHE sufficiently, engineering approach on working designs, manufacturing, and you can say, and construction procedures, continuously to do assessment for working, considerations for quality goals in all works, fixed quality in Bharat India, come what may, no excuse for concessions. This is, you can say, a broad title, fixed quality in Bharat India, come what may, no excuse for concessions. हमें क्वालिटी को हमारे देश भारत इंडिया में फिक्स करना होगा, सेट करना होगा, चाहे कुछ भी हो जाए। इसके लिए कोई क्षमा याचना नहीं दी जा सकती, कोई भी कंसेशन नहीं दी जा सकती, कुछ भी क्यों ना हो जाए। अगर हम वास्तव में भारतीय हैं, भारतवासी हैं और अभियंता वर्ग के लोग हैं। Really, if we are engineers, belonging to this country, Bharat, India. We have to prove that we can do. We can do, we say. We can do, or we have to do, not that we may do. We have to fix quality in this country, and that's what I say. Usually I say in different terminology, and that is get up quality. Don't sleep. Stop sleeping. In hours, and when I say hours, ours means country name, ours is society of this country, and that is India, Bharat. Ours is that. When I say ours means India is ours. This means is that. हमारे देश में सोइए मत, सोना रोक दीजिए, उठ जाइए, क्वालिटी देवता उठ जाइए. हम देवता कह रहे हैं रिस्पेक्ट देने के लिए, हालांकि करना हमको है, लेकिन एक ख्याल जगाने के लिए, जस्ट टू awaken souls of everyone, particularly souls of the sleeping community of engineers. I'm just trying to use certain phrases that may fit in some people. And even if say 25% to 50% of our community people, engineering people, start thinking of quality mandate, I can change whole scenario. It can change whole scenario. You can change everything. It's question of sharing responsibility. Responsibility sharing is very important in profession, and that's why I've given many topics name here in this title, as it says quality works, quality works, question mark, question mark, question mark. Because we have to question ourselves, we have to question our works. If we don't question, nobody else will question. We have to question. We have to question ourselves, and that is first kind of investigation, self-investigation we call it. In our language also we say, you identify yourself first, you try to understand who you are. Quality works, how much can you perform? We have to estimate ourselves, assess ourselves, investigate ourselves, check ourselves, and apply whatever terminology you can do in that soul world of engineering. I am calling it soul world. Don't take it otherwise, because engineering is soul of every country. Without engineering, practically, physically, nothing is going to happen. Nothing happens on this mundane earth. Mundane I am using because earth is mundane earth because of natural materials, and I am also natural, you are also natural. Quality works is a starting point, and then it goes to concrete specifications, which means specifications are always concrete, as well as we have to infer, we have to talk of concrete material specifications. Both are, you can say one way or other. We talk of specifications which are solid one, which are concrete one, and also material concrete. We have to talk, which is very significant point from civil construction, civil design, and engineering point of view. Field, when we talk, I talk of field in engineering and engineering field. Field means not just site, but base of site, backing of site, and that is design, and that is contemplation based field and all that. Engineering means every part of engineering, from inception to delivery and maintenance and service and life. And then engineers of course come into picture when you talk of life development, world development, country development, our development, every development, engineers come into picture. And of course then we talk of contracts, what sort of contracts are required for designs and constructions, and we have systems for that, for example IS 9001 or Sigma or whatever else is relevant to that. And we talk of contract books, FIDIC, IS 9000, though they are different one. FIDIC resembles to contracts and ISO 9000 resembles to quality, but we should not forget both are together in practical life. Without quality, contract cannot be done, and without contract, quality cannot be done. Both are brothers or siblings, you can say. The organizations are different, no problem, but when we work, we have to work together using them and using not only quality and zero. And I think this may work or may not work. I can't say. Maybe this voice at this moment I not being recorded and signals are telling they are going though. Maybe this video closes soon. I can't say. And there's no recording this way, so I'm not encouraged currently that this would work. But let us see what happens. Does it work or doesn't work? Something has come. Let us see. But the frame is very low. Maybe it doesn't work to frame. Now something has come. Well, it depends. Sometimes it is good, sometimes it is bad, so it comes in our way. And we can say then designs and construction are together because construction follows design, and executive designs and working designs come during construction, or you can say engineering designs come during construction, or engineering comes during construction itself. That's another engineering, of course, part of engineering, or you can say coordinational engineering, you can call it. Whatever kind of engineering activities we perform during construction is called coordination engineering. And then we have to see, then of course when we say contracts also come into play during construction, because operations of contract clauses are done during construction itself. And then methods means execution method, procedures, and how to do certain activities also called methods, and we have to deal with methods. So these are all linked activities. We cannot say these are separate disciplines. And then when contracts come into picture, certain disputes of course come into picture, and disputes are short-term disputes or small level disputes or higher level disputes or site organizational disputes, or you can say these go to disputes resolution mechanism, whatever is that. And then we call them organizations, and of course floating, and you can say a kind of statement here, communication, coordination, which move with every part of these activities. So though I got back my title with that. This title, now you think, where do we say? We say get of quality. Now quality means what? As an engineer, what do you think about quality? As an ordinary citizen, ordinary person, what do you think of quality? As a consumer, what do you think of quality? Means we have to think of this. Now as an engineer, I think everything is quality. You may say, I can say yes, it is quality that plays everywhere in life, everywhere in systems, everywhere else. Means that's why quality system has been devised. And system means a system's quality, and you can say construction means construction quality, and you can say design means design quality, or you can say manufacturing quality, or you can say quality everywhere. It means there should be some definition of quality. It may be virtually defined, formally or not defined, doesn't matter, but this should exist somewhere. You cannot separately say, no, this is that quality and this is quality. Quality is quality. Quality itself is an engineering term, and engineering itself is the quality of life. You can say without quality, engineering cannot move, engineering cannot move without quality, and without engineering, quality cannot move. It's like that. Quality is in life, it's everywhere. Life itself has many classes of qualities, means it's social life, or it's professional life, or it's public life, or it's political life, or it is service life, or it is, you can say, whatever name you give to life, quality is automatically imported or integrated with that world. Everybody has certain qualities, so it may not be formally defined, but everyone has. And that quality must be identified, and particularly when we talk of engineering production, when we talk of engineering development, quality plays its role excellently well if you follow it, if you respect it, and it plays very bad role if you don't respect it. Now what do? We respect it or disregard it? That's what we have to see. If you respect is fine, it's acceptable, you respect it, and do it, and remember that you do something past, you do something constructive, it takes a lot of time. It's very difficult to construct something, and you can say it's very easy to demolish or to destructure something or to dissolve something. It's very, very, sometimes you can say out of imagination, I can say it's very, very difficult to construct something, to make something, rather you can say. Making is very difficult, it is time consuming, it's hard job, it's costly job, it's time consuming, as well as it is to be taken care of, because when you construct something yourself honestly and sincerely, you feel that you have done something, you feel pleased with that. But the same thing, somebody breaks it, you don't feel that it is good. You feel, you pinch something, the heart and mind, what I have done. I spent a lot of time and hard work on this, and this person has broken it. You can feel difference of two. Means if you have contributed something to some production, some making, and somebody destroys that, how do you feel? You can yourself compare feelings of both cases. When you make it, your level of climatization in your mind, and you can say when somebody breaks it, how do you react? Both you can imagine yourself. And that is where difference lies in. And I say, when I say get of quality, I talk very responsibly here, because nobody wants to see quality sleep, but quality is sleeping. Nobody wants to be happy. Even someone is dishonest or not sincere, that person shall also not like to see quality missing or quality absent, because it applies to everybody. Even in your family, it applies on many activities, on many materials, and even your wards, your kids who are under education. You always desire that your kids should be good in education, your kids should have quality education, your child should have quality life. Everybody has such desire. So they may not use term quality, but they may use some other term in place of that. But here is a standard word, and we call it quality, and we may call whatever in other languages. But requirement is same, explanation may be different, name may be different. And that if it sleeps, I say sleeping, this means it does not work. Here, because first of all, it is not entity. Quality is not entity. This is, you can say, declaration within some work, within some product, some, you can say, whatever we use it for. That it doesn't exist physically, but it indicates through existence of material or product or good. What is conduct of good? What is composition of good? What is performance of good? What sort of service good gives? Does it comply with what was expected of that? If I expected something of this to perform and it doesn't do that, or if it does more than that, I'm happy in that case. Oh my God, it's value added service. Something additional has been given in terms of value, and I feel pleased with that, I feel honored with that. Oh my God, this is very good manufacture, I can trust this person. But it is reverse, in that case, I don't have any explanation, I don't have any expressive mode what to say. Maybe sometimes you feel angry and you can use very bad words, very abusive words for that, and that's often nothing wrong with that. So I say get up quality. This means quality either sitting without work or it's sleeping, whatever you can say. If it is sleeping or it's sitting or relaxing or it's ignoring, then we have to set it right, and that we can say, stop sleeping, my dear quality, come on, work. If you don't work, how can I work? I imagine quality is an object. I imagine quality is a person. So my dear person, get up, don't waste time. My time is not for wasting. You get up, do it, come on to me, and we both work together. And that's where I see we both work together. I have to work with quality. I cannot work without quality. So quality is my friend, quality is my colleague, quality is my relation, quality is my sibling, quality is my parent, quality is what are my children. All are quality based. You may imagine this, how I'm talking about. Yes, that's right. I consider my friend, and I consider myself within me. It can be There's no proper address but location everywhere. So I consider that way. Stop sleeping quality. I'm not sleeping. You can't sleep. If I am not sleeping, how do you sleep? You have no right to sleep. And I'm not going to interfere with the right, but you have to work. And that's what I say, get up, come on, we go together to work. We go together to work. Alright? I'll get you food if required, don't worry. I'll get every entertainment if required, don't worry. But you have to stay with me. I can't move without you. I have that determination. That's my determination, that's my vision, that's my, you can say, scope of thinking, scope of doing, and I am rigid in that. To what level, degree of rigidity I have, I do not know, but that can be measured, but I have rigidity. And that rigidity means resistance. If you don't come, I'll resist, and you come, I'll say, okay, come and join this picture, join this work. And not only join, you dictate this work, you control this work. That's what is, I can say, quality. And these two small terminologies, you may call it get up quality, stop sleeping in hours. I'm using this word because I heard this word hundreds times in my career from many international persons. Many, those whom I never expected was mind of those, but now I worked with them. I understand international community, how they conduct. And that conduct is really based on culture, backgrounds of people, and of course it's internationalized in metropolitan world. Like a metropolitan means international metropolitan world, where many nationalities work together, and goal of all nationalities remains one, and that is project. If I respect those cultures, I have to respect their thinkings. Sleeping is that word. It's actually a refined form of you're idle, you're not working, you're not serious, you're not taking care of what is required to be taken, and that activity, that state of waste of time, waste of energy, carelessness, ignorance, or let it be at in that we can say sleeping attitude, sleeping mode. And we have to come out of that sleeping mode and you have to go to running mode or efficient mode. And that's where we can say, do not waste time. Whosoever you are, my dear quality, or whosoever you are, my dear friend, do not waste time, because you have to be my friend. And when I say friend, this doesn't mean same meaning as ordinary life friend. This means I have to fry you, I have to use you, I have to consume you. Can you understand? I am saying to quality, you are my friend, I have to fry you. Fry and friend are same. Fry and I want to fry, you are my end and I want to use you. And that is where profession lies in. If I can't use my quality system or quality requirement, or I do not understand what I have to do, if that is not defined, expressed formally, then I have to think what's best way to do that. And before doing something, I have to think many times whether or not what I am going to do is apprehensive, comprehensive, right, or what. That is very important point from every viewpoint. And I can say we have to link together that quality must work. In fact, simple answer is that quality must work and I have to work with quality. I have to force myself with quality. I have to force others to work with quality, and quality always stands with us. Quality never says I don't come to you. It automatically starts working when you start working. It automatically forces you to think. You have to think a lot. That's why I say quality does not charge any money. It doesn't charge anything. Rather, it gives you back something which it never took from you. So you are credited, you have credit free of cost. And that is quality system, quality work, quality item, quality whatever you can say. And operators of this quality, who they are? operators of this quality, user of this quality, conductor of this quality, whatever you can say, they are engineers. They are engineers who do something world, for world. Development processes, manufacturing processes, or you can say construction processes. Whatever we do, that is engineering, that is application of processes, application of methodology, or you can say methodology generated for purpose of application. And engineering is the widest word in profession which got no end. There is no end because it is not complete. Engineering so far, just like sciences are not complete, engineering is also not complete. Update continues in life. We have to be so serious about this, and we say we require to establish you permanently. Engineers can handle you successfully, and that is job of engineers. Basic job of engineer is production with quality. Quality production, quality manufacturing, quality construction, quality service, quality determination. If we understand that point, if every person understands that point and does it seriously, we can say we will find a different world, and that world is known to us, but we don't want to go to that level. We don't want to struggle in life, and struggle is required for every struggle, for every solution. Those who cannot struggle with quality, they only want to take profession easy or just for purpose survival. I can't think that they can force themselves, they can have resistance, they can have a determination to get into quality system, quality world. And quality world is very, very gross world. In fact, engineering world means quality world, because if engineering cannot give quality, nothing else can give quality. And it is unfortunate, you can say, rather I should say it is nonsense that this point is not well understood. And even those leaders who are engineers in terms of law, in terms of education, they themselves have lost leadership practically because they do not understand how to give quality, and they have forgotten it, or they may not be able to know how quality is done. And I'm talking about my country, but in fact this applies to many other countries same way. We are no different in gas, of course. We can say we are no different, and engineers can handle very successfully, handle U quality successfully. But you are very correct also. You are right in your statement that engineers do not take care these days, and they take it lightly. And that's why I read some reference that life of structures, life of products, life of goods shorten because of bad quality. If a structure could work, say, for 150 years, we cannot allow it. It may be finished or gone in 50 years. You can say 1/3 life of that expectation. So if we do not care for quality, it is very much sure that quality shall not take care of myself and my work. And if I don't work with quality, I also have a habit of not to worry about quality, and that leads to improper answers, or you can say unexpected results. Therefore, we say we require to establish you permanently. You have to establish in our system, in our working. If we are unable to establish you, then we are nowhere, because it's your own, it's my own, quality is my own, it's my domain. I have to work, but I ignore, and quality does not understand meaning of ignore. It then runs away or destroys what is wrong. Explanation can be given to whatever extents. That can be improvised in thinking. There's no need that I should have some written document. Having all these points which I am speaking, some refer to this page, some don't refer to this page, some are, just based on thinking. And that is where, it is very important point that We have that capacity, we can speak, we can think, we can contemplate, we can think on issues that we have, and then try to find its solutions. And as finding solution, applying the solutions is of course certain definition of engineering as well. We say have active quality performing applications, and this is also a very important word. Applications mean engineering applications, solutions applications, problem solving applications, question answering application, and all those applications should come together so that we can say construction can be done, or you can say treatment can be done, or something is not available, it can be created, it can be produced. And for that there are various ways, various subjects of theory we learn, various subjects of engineering education. In education we do, and then we go to field in profession, and we work on designs, we work on construction, we work on manufacturing, of course after learning about what is to be done. So active quality performance is not just one day job, it's not just minutes or hours job, it's a job based on years together. Sometimes you work for many years on some project, but even then something you do not know of that project. It is possible because we keep ourselves isolated from coordination engineering, we keep ourselves only for subject engineering, and that is where we defect ourselves, we differ ourselves, and we are our own enemies in this case when we don't want to open our minds, open our eyes, and disseminate whatever we have to others who do not have. But again, point is, it is sincerity and maturity that is required in engineering, and particularly in construction engineering, which is development basis, without which nothing can happen. Construction based on some other economical factors which everybody knows very well, but we are talking about economy of materials, economy of how much we can save. It's not because we will save something for house or for construction, but something should be saved for natural sustainability. Nature should sustain adequately. All persons belonging to nature must sustain life and can lead good life. That's also a very important point. You can say we require to establish it permanently, have active quality performing applications, quality SHE sufficiently, engineering approach on working designs manufacture, and that's where we say means SHE is very adequately required. You cannot take risk and have people involved in accidents. That's not. We have to be actually quality performing applications. We have to take care of safety, health, and environment of people, and that's also preferable than work first, because one should be safe, one should be healthy, one should have good environment to work, and that environment is very important item. Health is very important item, and of course when you say safety, which is of course required everywhere, without safety in your personal life you cannot expect safety from all these agencies owned by nature. We can say then quality SHE sufficiently done. Yes, we have to think of that part of quality involved with safety, where everybody should be sufficient, should be optimally able. One should work in optimum way, not to waste undue percentages of your proposals. So you may say that safety, health, and quality. Safety, health, and you can say environment are significant part of excellent surviving a system in quality. It's not directly involved, but it's indirectly involved. When you keep fresh, you have good ventilation, and you don't care for AC, that's where you are welcome in that case. And of course virus can impact and whatever, but I'm not talking of that. I'm talking of that we have to establish ourselves health wise, safety wise, environment wise, and we have to fulfill all requirements that you yourself think so is necessary. What do you think is necessary? An engineering approach on working designs manufacturing, and that's what I say, particularly working designs and manufacturing, and that's very important point. And manufacturing and and with construction procedures, continuously to do assessment for working, considerations for quality goals in all works. That's point here, and exercise of fixed quality in, and say Wolfsnall works fixed quality in Bharat, India, come what may, no excuse for concessions. And then we can say quality works quality cannot be compromised just in name of fragile quality system compliance. Formality and excuse quality system may fail, but works quality must perform, be delivered. But does it happen? That's a question mark here, and I have to just confer on this how to do that. That's very, very important point. We cannot simply remain silent on quality issues, just thinking this certificate this company has got from independent agencies or from whosoever responsible, who can raise questions to people who are involved in quality and who can, for purpose of improving, that person, that teacher, should be with us all time in terms of our souls. And we have to be very careful about this, that we have to, 2 points, we have to care about system and we have to care about product. We cannot say forget product and think of system. If system is regulated well, automatically it would work. That's not a wrong point. But question is, what is regulation? And that regulation is self-control. Self-control of your life, self-control of devices. Do not just move exactly in a way you moved. We have to be very careful about this type of talk. When we talk of that system can be fragile, and that is true, because system is operated by people, by many people, and everybody is not smart to that level. Or you may say one may get something, some interpretation of system, and other person may get another interpretation of system. And that's also a very important point, that how can we infer what is required and what is not required. So we can't be slave to something, but we can, it's no question of slavery here, it's question of survival here, it's question of quality product here. So our system, when we design ourselves keeping abreast experience, keeping abreast knowledge, and then we can say, okay, this is best way. We can be in touch with everybody in system, and that touch is not just by statement, that touch means by contemporary arrangements, just to think how this preparation goes on, how do we think about each other, and how do we get information. That is very important for that viewpoint or application, and that also must come in some fixed time before doing something else. And if you miss that, this means that this can be called, this work is substandard, or you cannot comply with requirements, and then in that case we can say this is either disregarded work or this is not work as expected. So we have to think of another proposal so that that work is set right, or if we cannot set it right, then we have to remove that work. So system is important to some extent, you can say from efficient performance, but not for original performance, because we cannot do anything that because of us it goes off. There are so many metals available in solar system and in this space, and we have to check those, and that's where we can say, okay, fine, that I believe in this system because this system helps me. Does it help me or it doesn't help me, that's different, but you have to consider that it helps you, and then it will call that yes, we are complying with the system, and we update the system also depending on their requirements in life. Then we can say this is system, but ultimately system never stops, system has to deliver. And what does system deliver? That is examined thoroughly, and that thorough exercise, when it's opened, it gives you a real picture of what existed there. It's very, you can say, we have to be very serious about this issue, particularly quality, and seriousness is very significant in those minds which are very active. And here significance does not mean that you come to home odd times, our home. Question is that even if somebody stays in rented home, then that person has to respect that system. And same if somebody works in water, water tanking arrangement, fire tanking arrangement, or whatever sort of, you can say, controlling arrangements, one has to know its implications, its scenario, its procedures, and then we have to think on again and again for every new act what sort of problems we shall find in this from this viewpoint, and we use this term, you know, what do we call it, taking care about activities. We take care about activities, and taking care of activities means taking care of planning, doing, applying, and then detailing. Out of this we move together, and that's where I stress always, quality is a requirement. It's not your choice, it's not my choice, it is natural choice. And how it happened, only those people know. I cannot say how it happened. This is where we are serious about, we have to be serious about. And all these missing requirements that we are referring to, quality requirements, must be checked again and again. And I always sometimes think why I speak this much, why do I think relevantly. But when I reconsider my own words, my own phrasing, I see yes, I was not very active, and maybe that is due to being not happen with what you think. So red lines are to be resolved, which we can say we have to resolve. Otherwise, you can say scenario in our life is very different. If we cannot change environment to quality requirements, it's really unimaginable. And that's what I say, can we know and apply quality standards complied with or complying with overseas or international contexts, international deficiencies, international redundancies, as well as international polishing. This is a very important viewpoint, and we can thought of this. We then say, can we know and apply quality standards complied with overseas, for example, GCC countries in the Middle East, and likewise, why should we not do that? These questions shall be answered gradually, but purpose of this page was just to apprise you what we have to do, what we have to think. You cannot stick always to certain agencies. So this is some activity for you. About that is about concrete, files. We discussed this. We discussed with Page this concrete technology. There were so many definitions in this, so many terminologies in this, and we went one by one. And then we tried to understand what these are, and I tried to find more information from American stocks, but they want to price stuff for that. It doesn't matter. You must with him. You do not help yourself, you let yourself help. Since you become a king. Well, there are so many concrete technologies, hundreds and hundreds. We cannot go through all. We have gone through some, but these are sometimes very important to say, and we should read them. It's not very big page, only 80 pages in a first size. So I think from book point of view, this very big size. It's not that big. That's very anxious point. Now, concrete, when we say concrete is such a material that everybody knows, maybe you don't know why name concrete technology, but otherwise everybody has seen it who is in adolescence life. Concrete means solid what? Solid material, and concrete means life of that material in which concrete is used or included permanently. Therefore, we have to care about concrete as much as we can do, and if we don't care about it, doesn't go well. So you can say so many terms are available, and we can say, for example, we go back and see what terminologies are there, and we can find really it is interesting one. For example, let us say so many terms are here available. So let us see, for example, zero slump here. You can see the zero slump. Let me just blow down this so that we can see that very well. It is here, you can see zero slump, and we can have here, zero slump here. Then we can say this is only, zero slump. Here it is. Then yoke, yield strength, yield point. We have yield, yellowing, X-ray fluorescence, X-ray emission spectroscopy, X-ray diffraction, zonotite X-rays, wrapping wire, woven wire reinforcement, woven fabric, working stress design, working stress working, load workability, work wobble, friction wobble coefficient, wire wrapping, wire mesh, wing pile, wind load, weight cement, why we load wetting agent, materials like this. There are these are very important one. Now we also discussed some other issues, and that was about concrete related, which we discussed for here. I think it is ensuring quality and durability, concrete quality. Then let us say, for example, this concrete quality is also a file. I think we have taken care of this file. We have done this concrete quality we discussed in that paper. So we discussed this about what is that. So we can say we have done it. I think we have some on this page. Portland cement we discussed, etc. on this, and we have some here. Understand dynamic response of concrete to loading, practical experience it was. So let us see what is that. Design and engineering of biogas plants, I think, and before that it was low permeability concrete, environmental degradation of reinforced concrete. It was, I think we have done this, right? We have done this. Calcium solution, so it is performance concrete, the method of specifying construction process. Let us repeat how it is, what it says. I think we have done it, but let us see how sure I am. A performance concrete, for example, a performance concrete, we can say, for example, is a concrete quality. Now, when this is performance concrete specifications, a method of specifying a construction product. Performance concrete specification is a method of specifying a construction product. When you say, how does it perform? So we are talking performance concrete, right? That is a specification, is a method of specifying a construction product in which a final outcome is given in mandatory language in a manner that performance requirements can be measured by accepted industry standards and methods. It's something commendable, Performance concrete specification is a method of specifying a construction product in which a final outcome is given in mandatory language in a manner that performance requirements can be measured by accepted industry standards and methods. Process, materials or activities used by contractors, subcontractors, manufacturers and material suppliers are then left to their discretion. I'll come back to this. And what's before that, let us see. Before is let us come back to this and see how does it state. It says here, what's that? Where is gone? Some page is missing, I think. As far as I would say here. This is Portland cement, clinkers based largely on Belite, Portland cement clinkers based largely on Belite, and that is C2S can be made using essentially same equipment and technology as are used to make Portland cement. As are used to make Portland cement, you can see the main drawback is that they gain strength very slowly, and that is about, for example, Portland cement clinkers based largely on Belite can be made use using essentially same equipment and technology as are used to make Portland cement. Main drawback is that they gain strength very slowly compared to ordinary cement. This is, however, an advantage if they are used in massive concrete, where a low rate of heat evolution during hydration is desirable. Low rate of heat evolution during hydration is desirable. Another possible alternative is to add yeelimite. Yeelimite, that is Ca4Al2Si2O8. Yeelimite, also known as calcium sulfoaluminate. Calcium sulfoaluminate and also yeelimite. To balytic clinkers, we are talking of Belite here, balytic clinkers, that is impure C2S. So it says calcium sulfoaluminate, that is Ca4Al2Si2O8, and then the possibility to add this yeelimite to balytic clinker, and calcium sulfoaluminate cements have been developed mostly in China but are still too expensive except for certain niche market, for instance in certain stucco application. So it's a kind of just figure is not available, so I don't worry about that. We just try to understand what actually talk about. We may say performance versus prescriptive specifications. Performance versus prescriptive specifications. In our approach to mixed designs, we still rely mostly on prescriptive specifications, that is, specifications most often include requirements such as minimum binder contact, maximum water binder ratio, type of cement, types and or amounts of admixtures and filler materials, and so on. Unfortunately, while such specifications served us well in past, particularly when cement and concrete industries were less sophisticated, this inhibit most efficient use of many materials available to make up a concrete mixture. Such specifications also tend to be very conservative and are not very receptive to new materials or processes. It would be much more efficient in terms of both sustainability and concrete quality in general to move more aggressively to performance-based specifications. There are a number of different definitions of performance and performance-based application. But performance-based specification, there are a number of different definitions of performance-based specifications, but their essence is contained within Canadian standards CSA A231, which reads in parts, and that is what says performance concrete specification is a method of specifying construction product in which a final outcome is given in mandatory language in a manner that performance requirements can be measured by accepted industry standards and methods, process, materials or activities used by contractors, subcontractors, manufacturers and materials suppliers are then left to their discretion. What is their specialties? Methods specifying construction product in which final outcome is given in mandatory language in a manner that performance requirements can be measured by accepted industry standards and methods, processes, materials or activities used by contractors, subcontractors, manufacturers and materials suppliers are then left to their discretion. Well, intent is clear. I think it is very simple. Low permeability concrete. Low permeability is good one. Of course, if you have low permeability, it's good for us. Traditionally, first step in improving durability of RCC involved improving concrete quality, that is, for example, ACI 318 and ACI 357 recommend water to cementitious ratio 0.4 or under, and minimum covers of 50 mm for non-marine and 68 mm for marine works. So we can say in that case that water cementation ratio is 0.4 or under, and minimum covers of 50 mm for non-marine and 68 mm in marine exposures. So 50 mm and 68 mm, 50 mm in non-marine areas and 60 mm in areas which are alert. And we can say 60 mm in marine exposures, so ACI 318 2003, ACI 357 2003, other codes such as Euro Code 2 and Norwegian Code, that is N5 3474, and are less contingent than for this. Then we can say 3 ACI 318, 2003, ACI 357, 2003, other codes such as Euro Code 2 and Norwegian Code N5 3474 are less stringent. Additional means reducing ingress of chloride. Reducing ingress of chlorides into concrete involves additions of pozzolana or ground blast furnace slag. These materials are often added as cement substitutes. They react with calcium hydroxide to reduce coarse porosity. Calcium they react with calcium hydroxide to reduce coarse porosity of concrete and to decrease porosity at paste aggregate. Interfaces. Several conference proceedings document positivity benefits of these materials. Now, numerous references shown tell even if concrete is produced to most stringent requirements of codes, chloride ingress into concrete. Chloride ingress into concrete and corrode steel reinforcement. Even for very low permeability concrete, chloride eventually ingress into concrete and initiate corrosion. When chloride ingresses, so we can say even for very low permeability concretes, chloride eventually ingress into concrete and initiate corrosion. When chloride ingress is modeled as function of water cement plus pozzolanas and pozzolana contents for various geometrics and environmental exposure, time to corrosion exceeds 25 years. Times to corrosion in excess of 25 years are difficult to achieve for low permeability concrete. It says when chloride ingress is modeled as a function of water cement plus pozzolana and pozzolana contents of various geometries and environmental exposures, time to corrosion in excess of 25 years are difficult to achieve. Time to corrosion in excess of 25 years are difficult to achieve because of when chloride's ingress is modeled as difficult to achieve for low permeability concrete. Thus, additional protective systems are necessary to meet extended design lives that are becoming increasingly specified now. So, what actually we say design and engineering of biogas plants. This is reactor material and protection. Digestion tanks of reinforced concrete and steel are most widely used. Reinforced concrete tanks benefit from high tensile strength of steel and high compression strength of concrete. Appropriate concrete quality, that is blast furnace cement and low lime content, and professional construction are important to prevent corrosion and leaks in tank wall. So now it is referred to appropriate concrete quality, that is blast furnace cement and lime content, and professional construction are important to prevent corrosion and leaks in tank wall. Concrete digesters can be built. Concrete digesters can be built partially or completely in ground. Concrete digesters can be built partially or completely in the ground. Steel digesters are built on concrete foundations above ground. Steel plates are welded or bolted together. Steel plates are welded or bolted together and seams are tightened. For parts in contact with corrosion fluids, highest quality stainless steel is recommended. Glass coated or galvanized So, what is say? Says concrete digesters can be built partially or completely in ground. Steel digesters are built on concrete foundations above ground. Steel plates are welded or bolted together and seams are tightened. For parts in contact with corrosive fluids, highest quality stainless steel is recommended. Glass coated or galvanized steel is used when there is no risk of corrosion. This is glass coated or galvanized steel is used when there is no risk of corrosion. Vulnerable parts of reactor should be protected. Vulnerable parts of reactor should be protected by coatings or liners in order to avoid corrosion. Substrates, biogas, and condensate can contain aggressive substances. Substrate, biogas, and condensate can contain aggressive substances, and these are namely, you can say, these are hydrogen sulfide, that is contain aggressive substances, hydrogen sulfide, ammonia, organic acids, and even microbes that disintegrate concrete and plastic. Hydrogen sulfide H2S, you know this is a gas, and ammonia NH3 is also gas, various organic acids and microbes that all these disintegrate concrete and plastic. In steel and concrete reactors built from high quality materials, zone in contact with substrate does not normally need protection. But zone in contact with gas should be protected by plastic layer in order to resist small deformations or hairline cracks in materials. It must also be resistant to temperature variations. It must also be resistant to temperature variations, humidity and to aggressive substances that may be resident with reactor. Very important discussion. Really, you can say statements underlying. In chemistry, a substrate is typically chemical species being observed in a chemical reaction. Substrate is typically a chemical species being observed in chemical reaction which reacts with a reagent to generate a product. It can also refer to subsurface on which other chemical reactions are performed or play a supporting role in a variety of spectroscopic and microscopic techniques. Substrate chemistry, ground substance is an amorphous gel-like substance in extracellular space that contains all components of extracellular matrix, except for fibrous materials such as collagen and elastin. So what defined is substrata, a natural environment in which an organism lives. That's in biology, but we're talking of engineering. So in chemistry, if you say substrate is typically chemical species being observed in chemical reaction. Chemical, you can say species being observed in chemical reaction, which reacts with a reagent to generate a product. So that's what it says. Now we go back to here, and here is our point that we're talking of. So here what it says, if you just read again, it says in steel and concrete reactors built from high quality materials, zone in contact with substrate, we can say lower level, or substrate does not normally need protection, but zone in contact with gas should be protected by a plastic layer in order to resist small deformations or hairline cracks in material. It must also be resistant to temperature variations, humidity, and to aggregation of volume. Now, substance that you can say it must also be resistant to temperature variations, humidity, and aggressive substances that may be resident with reactors. Bitumen emulsion paints for underwater use. Bitumen emulsion paint for underwater use. Polyurethane. Polyurethane is the better one is bitumen emulsion paint, it says, and of course it is poly. It says that polyurethane, that's like epoxy. You can say polystyrene also or epoxy are used for coating. So bitumen emulsion paints, that is for underwater use, and polyurethane, polystyrene or epoxy are used for coatings. They are applied by painting, spraying, or by spatula, and must form a tight and completely covering layer. Application of a primer can be helpful, especially in case of rough surface. Lining sheets are another protection option. Polyethylene tiles or films can be set up in cast form and sealed with concrete. Understanding dynamic response of concrete to loading. Practical examples. Improving blast resistance. Research and development and engineering is directed towards practical application. Usually, active projects are much more complicated than textbooks examples. Reader can, it says that reader can understand that the projects chosen cannot be described in such a way that they are unidentifiable. Also giving physical data, geometrical sizes and charge weight or concrete quality is avoided. Now we have examples show practical importance of concrete materials for protective structures. We already discussed that, but just to review that. Mitigation of explosives. Mitigation of explosive effects using sandwich walls. Now, the project had two objectives. First is to assess existing building, and secondly, if necessary, design it to be blast resistant. First is to assess an existing building, and secondly, if necessary, design it to be blast resistant. For an existing building, the threat level had risen. Threat level has risen, and this had led to assessment that the structure was not strong enough. Therefore, a new design had to be developed without changing original architectural layout. Sandwich walls can be very difficult, but very efficient. Sandwich walls can be very efficient in mitigating So what you say here that therefore a new design had to be developed without changing original architectural layout. Sandwich walls can be very efficient in mitigating explosion effect. In present situation, a close-in explosion in the present situation, a close-in explosion and resulting blast had to be considered. Now there are various plates not shown here. Now we say show 3-layer wall. It shows a load transfer concept. A 3-layer wall is comprising of first concrete layer, an interlayer, and a second concrete layer. Second concrete wall. Concrete is a typical ordinary concrete type. Interlayer can be air. You see, concrete, when we talk of concrete, is a typical ordinary concrete type according to code, Eurocode. Interlayer can be air, foam, dry sand, or whatever that results in high impedance, as can be seen in plate. Blast wave hits first concrete wall. Blast wave hits first concrete wall. Coming from left, this results in a compressive shock wave traveling through material. At interface between first concrete wall and interlayers, a part of shock wave is transmitted to interlayer, depending on impedance, and a part is reflected as tensile wave. Part is reflected as tensile wave and transmitted to interlayer. Shock wave is transmitted to interlayer, depending on impedance, and a part is reflected. Part of what? Part of this shock. Ratio of transmitted ratio of transmitted and reflected shock, transmission to interlayer, and then reflection, ratio of transmitted and reflected shock wave depends on impedance ratio. Impedance is defined as product of density and wave velocity. Density and wave velocity. Concrete has a density, we know, 2.5 ton per cubic meter or 2500 kilogram per cubic meter, and longitudinal wave velocity of approximately 700 meters per second. That is longitudinal wave velocity. That is per second, 3.7 kilometer per second. Is it? That is longitudinal wave velocity of blast, 3.7 kilometer per second, which yields an impedance of 9.25 MPa. MPa, that is, if you multiply this, that's how much? 25 175 sorry, 17 okay, 9.25 MPa. That is, this is much larger than impedance of air. This is much larger than impedance of air, and which weighs 1.225 kilogram per cubic meter. Wave velocity, and that is only 340 meter per second, but wave velocity of blast is 3,700 meter per second. So impedance is 416.5. This is, we multiply, as we said before, if you multiply product of density and wave velocity, so this is 2500 is density, and wave velocity is 3.7. So we can know this, and then that is impedance, and much larger than impedance of air. Wave velocity, and that is 1.225 kilometer, kilogram per meter cube. The wave velocity 340. If we multiply it with this one, we get 1.225 into 340. So 416 PA, not MPA, Pascal, not megapascal. So, and impedance ratio is approximately 1:22. 1:22, and we say impedance. This impedance defined as product of this. So impedance ratio here is 1:22. 1 is in case of air, and 22 in case of concrete. So this is 209. 209, 2 for 16 and 9.25. So you can say 9.25 and 4.16. So this is 209. 209, that is times this impedance ratio is 1 in case of air, and you may say 22 in case of blast. Air and concrete, air and concrete impedance is concrete is 22 and air is 1. From this it's seen that air is an ideal interlayer. Air is an ideal interlayer theoretically. However, due to practical reasons on construction site, construction technique and process, low density foams or other materials with small impedances were used instead of an air interlayer. Furthermore, a foam interlayer also serves as an impact cover for second concrete wall. If first one is damaged, as described in following paragraph. That's not given here. So we continue as reading principle of wave propagation. A damaged plot of protective sandwich illustrated in this plate is not seen here. Effect of impedance at interface between first concrete wall and foam interlayer can be identified. A small part of blast energy is transmitted through foam interlayer into second concrete wall. A small part of blast energy is transmitted through foam interlayer into second concrete wall. However, strain state in second concrete wall is much smaller than in first. We observe significant damage indicated by certain color, energy dissipation in first concrete wall. Energy dissipation. Significant damage indicated by red color, energy dissipation in first concrete wall, reflected tensile wave at rear face of first wall. Reflected tensile wave at rear face of first wall results in tensile stresses in concrete material, which can be much larger. Tensile stresses in concrete material, which can be much larger than dynamic ultimate tensile stresses. So we can say, as we said, reflected tensile wave at rear face of first concrete wall results in tensile stresses in concrete materials, which can be much larger than dynamic ultimate tensile strength of concrete. This leads to scabbing failure on rear face of first concrete wall, but foam interlayer was chosen such that prevents concrete fragments from impacting second concrete wall. Consequently, requirement that rear wall should stay in contact be fulfilled. So what it says, in fact, reflected tensile waves at rear face of first concrete wall results in tensile stresses in concrete material, which can be much larger than dynamic ultimate tensile strength of concrete. This leads to scabbing failure of title. So, So what we see, this leads to scabbing failure on the rear face of first concrete wall, but foam interlayer was chosen were such that it prevents concrete fragments from impacting second concrete wall. Consequently, requirement that rear wall should stay intact could be fulfilled. This also shows that tensile behavior of concrete is a significant design parameters. In next example, task was to harden an existing building. Task was to harden an existing building. Existing concrete walls had to be protected against a contact detonation. First, fire control authorities had formulated very strict requirements due to available space for hardening measures. In addition, protection requirement for existing wall was acceptance of certain damage. Therefore, a high strength, high ductility concrete was we can say first concrete authorities had formulated very strict requirements due to available space for hardening measures. In addition, protection requirements for existing wall was acceptance of certain damage. So we can say we have to harden that. Fire control authorities had formulated very strict requirements due to available space for hardening measures. In addition, protection requirement for existing wall was acceptance of certain damage. Therefore, high strength, high ductility concrete was developed. High strength, high ductility concrete was developed and analyzed. Now another plate, this is 3-layer concrete sandwich wall, 3-layer concrete sandwich wall subject to contact detonation. This is designed with high strength, high ductility protection, high strength, high ductility protection wall. Right is numerical simulation result that gives. In fact, now we are just on the detail. Let's see what it says. High strength, high ductility concrete will be described in following section. There is protective concrete will serve as a victim wall. Protective concrete will serve as a victim wall. Interlayer mainly provides distance and existing wall is damaged cap accessibility. We are often, now we're talking blast walls, and we are often asked to design blast walls, which give subjective feeling of being better protected. Better protected means we are often asked to design blast walls which give subjective feeling of being better protected. In fact, give protection from contact detonation. So we can say, yeah, they give subjective feeling of being better protected. In fact, protection from contact detonation, flying fragments, flat trajectory fire, blast in close range behind wall, and they act as blinds if they have to be designed in an urban environmental situation where in addition requirements from monument conservation authorities exist. It becomes a real challenge. Even design of concrete foundation can become a complicated task if trees have to be preserved or if supply and waste. They have to be designed in an urban environmental situation where, in addition, requirements from monument conservation authorities exist. It becomes a real challenge. Even design of concrete foundation can become a complicated task if there is. So we can say solution was chosen after several options were studied. Foundations are made of ordinary reinforced concrete carrying clamped steel posts, high strength and So here we can say foundations are made of ordinary reinforced concrete carrying clamped steel posts, high strength, high ductility concrete, high strength, high high ductility concrete panels protected from blast, contact detonation and impact. High strength, high ductility concrete panels protect from blast, contact detonation and impact because of their ductility of the weld. Because of their ductility, they can develop a good fractural behavior and consequently active membrane actions. Blast wall, high strength, high ductility concrete is a product of Deacons. This is now administration of that. Now it is about, we can say this blast wall. If I see terminology here, we'll find something. If we say blast wall, we see here, maybe here somewhere, you can see this. Blah 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 blah. It's not given. Blind point plus is not given in this. Blank test, blast furnace, blast. Blast while we are talking, so they are very important point. In fact, we talk something here. We can say. Let us see what it says about blast. A blast wall is a barrier designed to protect vulnerable buildings or other structures and people inside them from effects of nearby explosion, whether caused by industrial accident, military action or terrorism. We can see blast wall if you want to see. Can we see that? Blast wall, an overview, let us say science.com. A blast wall is a barrier that protects the structures and lives from explosive blast pressure, debris and fires. Black wall prevents fragmentation and fly rock. So let us first see this. Blast wall, we are talking understanding dynamic response of concrete loading, practical examples. Let me try if I can get PDF of this, if it's possible to get, or maybe I get only without sketches, without photographs. I don't think I'll get that one. I'm getting here, okay. I'll print out this and show it to you. This is also important point, and it can be better, science.com. So here is blast valve. Blast valve, and this is from Science Direct. Blast valve, this contains, let's say, blast valve contain an overpressure from an explosion. It contains, blast valves contain an overpressure from an explosion in a confined space. Overpressure from an explosion in a confined space from causing secondary damage on other side of wall. Then we have understanding dynamic response of concrete to load, practical examples. Understanding tensile properties of concrete. Okay, blast walls. Now there's a definition here. We are often asked to design blast walls. They give subjective feeling of being better protected. In fact, give protection from contact detonation, flying fragments, flat trajectory, fire, blast in a close range behind walls. And they act as blinds if they have to be designed in an urban environmental situation where, in addition, requirements from monument conservation authorities exist, it becomes a real challenge. Even design of concrete foundation can become complicated task if trees have to be preserved. We have already seen this, or if supply and waste lines across foundation. Now figure 11.19 shows why it's not, it's just coming. Figure 11.91 shows a cross-sectional view of situation, and B is a photograph of wall that has been built. Solution was chosen after several options were studied. Foundations are made of ordinary reinforced concrete carrying clamped steel posts, high strength, high ductile concrete panels protect from blast. High strength, high ductile concrete panel protect from blast, contact detonation and impact. Because of their ductility, they can develop a good flexural behavior and consequently active members action. So this is blast wall, and here is, you can see science.com here, 2 meters into 50, and you can see that. This is also another B. A is cross section and blast valve ready. You can see this is blast valve ready. You can see that. Okay, and here to protect this area, this is blast valve ready, and here is a section. You see this that section here, and this is 9 here, and this is gap of 66. This is exterior, this is interior, and this is air here. This is 42, 52, 2 meters, 250 here, and this is 90. So here is, you can say, so it says blast valve cross section is A and B is blast valve ready. High strength, high ductility concrete is product of Irocon. So this is completely leave it now. Now it shows Ducon sand and self-compacting concrete and micro mat. Compression strength goes up to 200 MPa and tensile strength reaches 75 MPa, which is roughly 40% of compression strength. Therefore, such materials can be favorably used with high tensile resistance required, where high tensile resistance is required. Design and analysis of composite structures. Offshore oil and gas platforms. Gas explosions aboard offshore platforms cost millions of dollars in lost income. That is in lost income. Wreak havoc upon environment, result in serious injuries, and cause devastating loss of life to platform occupants. Gas explosions aboard offshore platforms cost millions dollars and wreak havoc upon environment, result in serious injuries, and cause devastating loss of life to platform occupants. Since Piper Alpha disaster, the entire industry has become much more safety conscious, overhauling its maintenance protocols, design methodologies, and blast mitigation systems. Two are of particular interest here. Firstly, offshore platforms use a water deluge system. Water deluge system to prevent gas explosion. Firstly, offshore platforms use a water deluge system to prevent gas explosion, which is best example of an active mitigation system deployed in a civilian capacity. Once a gas leak is detected, entire area is showered with carefully sized water droplets in order to prevent ignition and remove energy from a vapor cloud explosion. What it says? It says deluge. Offshore platform use a water deluge system to prevent gas explosions. It's the best example of an active mitigation system deployed in a civilian capacity. Once a gas leak is detected, entire area is showered with carefully sized water droplets in order to prevent ignition and remove energy from a vapor cloud explosion. Remove energy from vapor cloud explosion. What it does? Once a gas leak is detected, entire area is showered with carefully sized water droplets in order to prevent ignition and remove energy from vapor cloud explosion. This occurs upon gas buildup, not ignition of gas cloud. In order to deploy in time to prevent deleterious effects, these systems are practical offshore because gas leak which accumulates relatively slowly can be detected easily, and there is sufficient time for water blanket to perform its function before a vapor cloud explosion occurs. So what firstly says, then there secondly, I repeat, firstly, it's very important. Firstly, offshore platforms use water deluge system to prevent gas explosions, which is best example of an active mitigation system deployed in a civilian capacity. And once a gas leak is detected, entire area is showered with carefully sized water droplets in order to prevent ignition and remove energy from a vapor cloud explosion. This occurs upon gas buildup, not ignition of gas cloud. In order to deploy in time to prevent deleterious effects. These systems are practical offshore because gas leak, which accumulates relatively slowly, can be detected easily, and there remains sufficient time for water blanket to perform the respective function before a vapor cloud explosion occurs. Secondly, offshore platform we can say offshore platform. Let me save this file. It's an important one, I think. It's a very important file. Secondly, offshore platforms employ blast walls which separate process parts. Secondly, offshore platforms employ blast walls which separate process parts of platform at risk of explosion from safe personal area, particularly area known as temporary refuse. Walls typically comprise corrugated panels and connections which are attached top and bottom to upper and lower decks, parts of primary structure. Corrugated panels deform plastically in central zones, and connections are designed to rotate about inch. Corrugated panels deform plastically in central zones, and connections are designed to rotate about hinge points in event of explosion. Walls employ containment paradigm containment paradigm in that walls employ containment paradigm in that they must not rupture and so must contain blast loading. However, panels plus their connections also use sacrificial system approach in that they must absorb energy from blast so that primary structure does not suffer serious damages. Stiffening connections would reduce deformation of panels but lead to higher loads being transferred to, to primary framework. So that there is a compromise made between two paradigms resulting in a hybrid protection system. Here is a sketch or you can say reference, a figure, primary framework upper deck, and this is I-beam representing primary framework, and these are corrugations. Here is angles comprising connections. Schematic of a blast wall. Additionally, choice of wall material is important. This wall you can see upper deck, angles comprising connections, corrugations, I-beam representing primary framework, and additionally choice of wall material is important. Blast walls are usually manufactured from stainless steel due to following characteristics of stainless steel. Corrosion resistant. Corrosion resistance suitable for harsh saline environment and normal operating temperature range. Valuable in an off-shear location. Relatively high melting temperature. So shall last an appropriate length of time in event of fire, which is a secondary event that usually follows a gas explosion. High strength, high yield strength, and ultimate tensile strength. High ductility, which when combined with its high strength means it absorbs a lot of strain energy without rupturing, important for both containment and sacrificial paradigms. There has been some recent work on potential of using fiber reinforced epoxy composites to limit blast wall deformation by retrofitting central region of corrugated panels. So we can say there has been some recent work on potential of using fiber reinforced epoxy composites to limit blast wall deformation by retrofitting the central region of corrugated panels. This is motivated by need to reduce central deformation so that items such as critical piping on platform can be sited closer to blast walls without them incurring damage in event of an explosion. Composites are ideal for this sense. They are lightweight, stiff, and are insulating materials. Full composite panels and connections have not been installed on platform as stainless steel remains preferred material. Domino effect, its prediction and prevention. Passive safety barriers. Passive safety barriers are generally physical measures such as coatings and materials for thermal insulation of equipment, firewalls, blast walls, which do not require external activation to perform their intended safety functions. They can be designed both as prevention and mitigation barriers. In specific cases of domino effect prevention, passive barriers are particularly important since these are immediately available when primary accident with now in a specific case you can say require external activation to perform their intended safety function. These can be designed both as prevention and mitigation barriers. Now we'll say the 5 more pages in this. We'll take up in the next session. It's a good one if you take this point, and already it's how many hours over? I think it's 2 hours. So I'll take a look at this now, and because I have to go now at this moment, we can say we'll take up this session next time. We'll take this session next time, and of course this we have to work on with. We have here all this. So